Okay, so now let's talk about the next thing. Like I'll start with what the difference between 2 byte and as instance of. Okay. Now, for example, let's say you want to convert one data type to another data type, right? For example, you have integer, you want to convert that to byte. Okay. Now, if that's the case, then you can either choose two approaches, right? Either you can use a 2xxx method, or you can use as instance of. We have seen a small demo of as instance of, wherein I told you that as instance of can be used to change the type from one data type to another data type, right? So let's see what is the real difference between these two triple X method and as instance of method. Okay, now I'll go through the document. What is the difference between 2 byte and as instance of? There are many 2xxx methods which can be used to convert data from one type to another type. Okay, and as instance of is a method which is present in any class. We know that, right? And is used to typecast any object to another compatible object. Okay, if you provide any two incompatible type, it will throw you a class cast exception. It's very important for us to learn about different exceptions that you might encounter. Okay, so that whenever you're writing a production level code and if something throws exception, you should be smart enough to understand that probably this comes because we're trying to typecast two incompatible types. Okay, or we are trying to convert one type to another type where that type is not compatible, right? Okay, now avoid as instance of and prefer to triple X whenever possible, because as instance of throws error if there are class mismatch. So what the major difference is, your as instance of is present in any class, whereas 2xxx is present in the data type specific class. For example, if you have a class called int, then go to the int class and see what are the 2xxx method available. Okay, now 2xxx can be used only in those objects whose class contains such method, which means if you're using as instance of method, there is a chance that you might actually try to like convert incompatible type, which might give you an error called class cast exception. Okay, whereas 2xxx method cannot be executed if it is not supported. Okay, so let's look into that. Now I'll go back to REPL and let's say, well, x is equal to 10. Now when I say, well, x is equal to 10, what is your x? X is basically an object of a class called int. Okay, and then what are the 2xx method that is supported? It's very simple. Just say x, just write dot and just say 2. Okay, and just give a tab. So it will actually give you the list of everything that you can probably do. Okay, see here there are methods called toChar, there are methods called toInt, there are methods called toLong, there are methods called toSort, there are method called toString, there are method called toOctal string, and so on. So all these methods are available in your x object, wherein x is basically the object of int class, which means I can actually go and execute all these methods and it will not throw me any exception. Okay, whereas let's do something like this. Well, y is equal to false. Now I know that y is a boolean type, and let's see y dot to give a tab. Now if you see, when I gave a tab, then it did not give me a lot of possibilities, but it gave me only one thing, that is toString method, which says, hey, your y can be converted only to string and nothing else, right? But if you use as instance of, then probably you might write something like this. I want to convert y to integer type by using as instance, and that would give you definitely a class cast exception, because your integer and false are two incompatible type, right? Like what is the equivalent integer of false? It's not 0 or it's not 1. Okay, that is not how it works in Scala and Java. Okay, so I hope you understood the concept. Like 2 byte and as instance of both can be used. This 2xxx method and as instance of both can be used to convert the data from one type to another. The only difference is as instance of throws you an exception if the classes are not compatible. Okay, now 2 byte or 2xxx methods are supported or not, that you can easily figure out by looking into the API. Okay, that's how you should be actually looking into. Okay, now similarly, if you want to go a little bit in more detail, just say int scala and go to this scala.int class. Okay, now I am here in scala.int class. Go little down and see if there are what are the two XXX method supported. Okay, you will get to know a lot from here also. So let's go more little down. We got it here: 2 byte, 2 char, 2 double, 2 float, 2 int, 2 long, 2 short, and so on. Okay, so it's very important for you to make a habit of going through the API documentation every time. Okay, make sure that you constantly go and check the API documentation every time. Okay, you may say, hey, are we not using the old API documentation? Yes, but that does not even matter. If you want to check the latest API documentation, you can still do that. There is one technique. Let's try that out. See here, scala-lang.org, I got API, and there is some version, right? So can I just blindly do something like this? Can I say 3.0.0 and let's see what it gives us. So it gave me Scala 3 integer class. Okay, now you got access to the API as well here. So if you mention the version here, then you'll get the API of that particular version. So what the current version that we are actually running on? Let's see. Just say :q to quit and just say Scala so that you see what is the current version we are using. We're using 3.4.0. That's the latest version available. So just say 3.4.0. You got an integer class from 3.4.0. Okay, go back, scroll a little down, and you should be able to see all the two method implementation here itself. Just scroll a bit more. So all these are methods. Okay, whatever you see with the def is used to define a method. Okay, so all these are methods, right? So if you see, all these methods are here. Okay, or else you can also do something like this: delete everything and go till API and hit enter. Okay, when you do that, it takes you to the current, and current is basically 3.4.0. And if you want, you can actually go back to this place and change the version as well. Okay, so that's how you will be basically able to go through the API documentation. Please make sure that you keep a habit of going through this API documentation every now and then, because that's what we do every day at work. Okay, whenever we feel we want more detail about something, the only place to go and check would be the API documentation. Okay, all right. So 2XXX method can be used only in those objects whose class contains such method. Okay, now let's look into this example. Let's see what we have here. So I wrote, well, number which is of any type is equal to 10. Can I do this? See, when I just say, well, number is equal to 10, 10 means int, and it would assign me a integer, right? If I don't write any, then by default the number would be of 10 type. Okay, but can I say let this number be of any type? Is this valid? Okay, so this is perfectly valid because 10 by default is of int type. And who is the direct parent of int, guys? Anyval. Yes, anyval. Okay, now who is the again parent of anyval? Any, right? That means I can say, well, num of any type is equal to 10. That's perfectly fine. I can say, well, num of any val of 10. That's also fine. Okay, or I can say, well, num of integer is equal to 10. All these three statements are perfectly valid because you can hold that 10 in an integer class, or its parents class, or its parents class, or its parents class, and so on. Okay, so since any is the godfather class of every classes in Scala, hence this is perfectly valid. Okay, now let me write something like this. If, see here, I wrote num here, right? Okay, and I'm saying if num dot is instance of int, num dot as instance of int into 2. Okay, let me do this. What I did is I said if num is instance of int, okay, which means I'm checking if my number is actually holding integer or not. If yes, then I'm saying okay, convert this num dot as instance of int, which means convert this into integer and give me back multiply it by 2. Okay, now let me show you one thing. This example, what we have executed, okay, if you're running this in Scala 2, this will return you back a value, but in Scala 3 it does not. Okay, so these are some of the minor differences, and as we move on with the whole course, you'll see all the differences between Scala 2 and Scala 3. Okay, so I'll just put a point here so that even if you are working in Scala 2, you should not have any problem. I would say this does not return value in Scala 3. Okay, in Scala 2, what it did, it converted that to integer and it returned you back a value. Okay, and let me do what? Let me try to do something like this. Instead of saying return, can I just say print? Will that not work? I'll just say print and let's do something like this. So it worked, is not it? So what I'm trying to tell you is, in case of your Scala 3, if you just write if condition with only one statement and you don't provide else condition, then you should not expect the output. And we will talk about that when we start looking into the if conditions. Okay, right now we are not discussing our if conditions, so let us not even move into that. We have a whole bunch of discussions for that. Okay, so what I did is I just said if num is instance of integer, if it holds integer, then convert this into integer, multiply it by 2. So 10 into 2 is 20, and we just printed that 20 here. Okay, so really I'll copy this and I'll paste it, and let me just say print like this. Okay, and the answer is 20, and I'll write for Scala 3. Okay, for Scala 3. So which means you should be able to understand that this code would print you 20. Okay, all right. Now let's check this example. If num is instance of int num dot to integer into 2. Okay, so it gave me some error. Okay, so let's check it out. What is the problem? Yes, here I'm saying num dot is instance of int. So what is your num? Num is basically your integer, but it is of which type? Any type. Okay, so if num dot is instance of integer, yes, it is true. This is perfectly fine. And then it goes to this statement, right? Num dot to integer. So the problem is it could not call to integer because see, num actually holds integer, of course, right? But then what is the type of your num? The type of num is any. Okay, which means if you have created an object of a child that is integer, and if that object is being held by parent that is any, then you can call only those methods which are available in any. Okay, parent object cannot call child method, right? Of course, and that is the reason it will throw you an error here. Okay, if you see the above example, as instance of is used for typecasting. However, toInteger is a method which is really not available in the num class object, and I would say any class to be specific, right? So do you see that I was allowed to call as instance of method here, but I was not allowed to call toInt method here. Why? Because toInt method is not available in your any class. Okay, so here the whole idea was to understand what is the difference between as instance of and to triple x. To triple x can be called if the methods are available in that class object. As instance is a global method, can be called across. The only problem is if you write as instance of method and if you're passing incompatible type, then it will throw you a cast class exception. Okay, whereas to triple x method can be called only if it is available. So I would always recommend you to use to triple x method to avoid any such runtime exceptions. Okay, now look into this. We've also documented node. The same program will give you a separate output in Scala 3.x. What is that? Let's see that. I'll say well num of any is equal to 10. Done. And now we said print. Okay, remember we have used a keyword print here. Okay, if num is instance of integer, then convert your num to integer type and multiply it to 2. It gave me 20 here. Okay, again, if num is instance of integer, num dot as instance of int into 2. It looks like you're trying to return this value back. Okay, and we have just tried printing v. Let me say print v. Okay, and it just give me something like this parenthesis, and parenthesis means it is actually returning you nothing. Unit. We'll talk about this unit in the coming classes. Okay, now if you want to be very sure that I want a return type, then you should actually also introduce else, and that's the thing that we are missing. Okay, that is what is the new thing that is implemented in Scala 3. In Scala 2, even if you write like this, it was actually returning you back the value. But if you want to do the same thing in Scala 3, then what you should do is write your condition if, and this is my if part, but also introduce your else, otherwise return me 0. Okay, now in that case it returns you something, but if you miss this else block, then it does not return you anything. Okay, so in Scala 3 it says if you're writing if, and if you want me to return some value, make sure that you also give me else part, so that I can at least return value if the if condition is not true. Now let's talk about all the data types, guys. Okay, we will explore all the possible data types in Scala. Okay, now first of all, like you have a data type in Java, you don't have a data type in Scala. That's number one thing that you need to understand. Okay, but whenever we say data type, we're actually not talking about data type, but we are talking about the data type equivalent classes. Okay, so if you talk about Java, you have 8 data types, right? In Scala, you have its equivalent classes. Okay, for example, you have boolean, okay, you have sort, you have int, you have char also, I missed it here, sort, int, long, you have float, you have double. Byte is here. Okay, so byte, boolean, char, sort, integer, long, float, double. So if you look into this 8 data types, now in Scala you don't have the data types, but what you have its equivalent classes. And remember one thing, a class name always starts with a capital letter. Okay, so when you see boolean with capital B, you should say it is actually a class because it starts with a capital letter. Okay, so you have int, you have capital I and T, right? So likewise in Scala you have got all the classes equivalent to your Java data types, and from memory point of view they are same, which means if I tell you that this byte is of 1 byte, then in Scala this byte is also of 1 byte. If I tell you that it stores the value from -128 to 127, then this Scala byte also stores the value from -128 to 127. Okay, so likewise you have 8 data types in Java and you have equivalent classes in Scala. Let's move on and we'll start exploring all these classes one by one. So we'll start with char today. Variable char is equal to a. So char means what? Character. Okay, so char is a type which can be used to hold a character from the user or anybody else. It can be used to hold a character in your program. Okay, for example, you might have seen some of the program like this. Do you want to continue? And you just say yes or no, right? That means you are asked to provide only one character, and with that one character the program would continue, right? If you ever get such requirement to store one single character, then you can use a character data type. Okay, so what we have is we have variable char c is equal to a. Okay, I wrote where c is equal to a, and what I got is I got c which of character type, and it is storing a. Okay, similarly let's say where I is equal to c. What is your c, guys? C is of character type, and I'm saying okay where I is equal to c. When I do this, this is just an assignment. Okay, so your c is holding a is basically a character, and I'm saying where I is equal to c, which means I will also store the same a. Okay, but can you tell me, if I write this, then how many objects are actually created, guys? One or two? What do you think? Only one. Okay, so what we have done in the first line is we said I want to declare a character a and I want to store it with a name c. Okay, I want to assign it with a variable C. So what happens in the memory? One object gets created. That object would hold A, and that is pointed to by C. Okay, and then in the next line you said where I is equal to C. That means I want to declare one more variable I. Okay, and that I should also point to the same C. Okay, which means there is only one object and they are pointed by two different variables C and I. It would be something like this. I is pointing to this, C is also pointing to this. When you say, well, C is equal to A, what happens? In the memory, one object gets created and C is just a reference to it. And when you say, well, or where, whatever, okay, I is equal to C, then this, references, they are just a link to the object. They are not a new object altogether. Okay, for example, people call me by Suraj, but if you see, I'm just a human body, right? And Suraj is just a name that holds me till I'm alive, right? So likewise, this I and C, they are really not objects. They are called as references, right? The real objects are created in the memory, and these are just the pointers. When I say pointers, don't get confused with the C pointer. We are not talking about C pointers, okay? But I'm just telling you that it's just a link to refer to that object. That's what you need to be very clear on. Okay, so let's move on. Let me do something different. Now, can I use something like this where J is of integer type is equal to C? Can I do something like this? You can. Okay, where J of int type is equal to C. When I do that, then what happened? J got assigned to a value called 65. And what is this 65? Let me tell you. Every character, whatever you type on the screen, they have got a ASCII code. Okay, so let's Google it out a little bit. I'll say ASCII code table. Okay, now look into this. This is basically a ASCII code table. Okay, which means every number, character, whatever you see are given a unique code, right? And if you look into our example, in our example, we have written capital A. And what is your capital A here? Check it out. We got another table here. You have capital A here, which is basically the character, okay? And what is its decimal equivalent? 65, right? Which means A has a unique code called 65. Okay. Similarly, B has 66, C has 67. So they are all in serial. A to Z. Okay. It starts with 65 and it goes till 90. Okay. And your small a starts with 97 and it goes till 122. Okay, so if you see, every characters are given a unique character. We call it ASCII. Okay, now this ASCII character is not a new thing in the industry. Okay, they are there since long time, but over the period of time, what the computer scientists found out that ASCII characters are not sufficient to hold all the possible values in the world, and hence they started another code called Unicode. Okay, now I'll also show you a Unicode table. So look into this. These are actually the symbols. Okay, they came up with a concept called Unicode, wherein you can actually store a lot of characters. You can store A, or you can also store some symbols like this. Okay, see here, this is not A, this is something else. Okay, so this is something else. So Unicode and ASCII, the basic difference is your ASCII can store only limited range, but Unicode goes beyond that and it can store any possible symbols in the world. Okay, but what they have done is, for capital A to Z, if the ASCII starts with 65, then the Unicode is also seen, so that there is no difference when somebody is migrating from ASCII to Unicode, which means Unicode was introduced later. Earlier it was all ASCII characters. Okay, so we used to call it ASCII code. Okay, but then when Unicode was invented, what they did is they said, okay, let's do one thing, let's migrate everything to Unicode, but we will not change the Unicode of whatever existed earlier. Okay, which means if capital A to capital Z is reserved with 65 to 90 in ASCII, then in the Unicode also we'll have the same value. Okay, the table is long, go and search it out and you should see that. Okay, but let me also show you some more thing. Maybe I would say symbol Unicode. Okay, now look into this. The beauty of the Unicode is you can actually use like all these emojis, whatever you see, they also have a Unicode. Okay, and if you are supposed to store it on ASCII, you would run out of space. Okay, the ASCII characters were very limited, and that's the reason. So let's go here. You might have noticed all these kind of symbols in the LinkedIn post and whatnot, right? So they are like all these have a Unicode. Okay, all these have their own Unicode. So that's how it works all together. Okay, now let's move on. When I said where j is of integer type is equal to c, what we saw that 65 was assigned to it. Why? Because c is equal to a and a Unicode is 65, and hence this j is 65. Okay, similarly, can I do something like this? Can I say, well, j, which would be of character type, and can I say is equal to 97? If I do that, then what will I be storing? I'll be storing a. Why I'm able to store a? Because this is basically a Unicode. Okay, the Unicode of small a is 97, and when you say 97, what is assigned? A is assigned to it. Okay, so what I'm trying to tell you is you can store a character in a character variable, but if you print it in an integer format, it gives you the Unicode. Okay, now let me do something like this. I know that the capital A starts with 65. I know that this A to Z series ends at 90. Okay, 90 is basically for Z. Now can I say something like this? 65 to 90, I used a loop. I want to go from 65 to 90. Okay, and for each such number, it goes to 65. Okay, this 65 would come to this number, and I'm printing number 2 character, which will give me a. I can convert a number to character as well, right? So 65.2 character gave me a. Now it is a loop. Next time it would be 66. 66 2 character would give me b, and we have given a space here because we wanted to print a followed by a space, then b, then followed by a space, and so on. Okay, and hence this actually printed a to z. All right, so you can either write something like this, or you can also do something like this. Now let's see what the warning it is saying. There was one deprecated warning, rerun with deprecation for details. Okay, we don't care about this right now. Okay, so let's go to this code. Look into this. Now it did not give me the warning because I know what was the issue there. So again, it's the same thing, 65 to 90 for each number, print number dot to character. And whatever we have written here, it's basically called as string interpolation, which we will talk about later. Okay, right now our agenda is not to teach you for each. Our agenda is not to teach you the string interpolation, but our agenda is to help you understand how the 65 to 90 can be represented a to z because of the Unicode, right? So which also means, can I say, well, v is equal to 65? Of course, yes. And what is of v type? V is of integer type. Okay, now if I say print v, it gives me 65. If I say v dot to char, do I have any something like this? Yes. If that's the case, then it gives you the character version of 65, which is basically capital A. Next, now let's talk about integer. Okay, any whole number is by default treated as integer if it falls within the range. Okay, so let's check this out. So if I say, well, x is of integer type is equal to 10, that's an integer. Okay, if I don't write this, then also it is an integer, because any number by default would be treated as integer if it falls within the range. Okay, similarly, let's do something like this. Well, x of integer is equal to 0x12. So when I say 0x12, it is basically the hexadecimal representation. Okay, so hexadecimal representation of 0x12 is 18. Now how it is 18? Let's see that. 0x12, right? So see, when we talk about number system, you have binary, you have octal, you have hexadecimal. Okay, binary means 0 and 1, right? For example, if I have a number, let's say 15, and if you have to find out the binary, let's say this is a decimal number. Okay, if you want to find out the binary of it, then you should constantly divide it by 2. So you will say 2 7s are 14. What is the remainder? 1. Okay. Again 2 3s are 6. What is the remainder? 1. Again 2 1s are 2. What is the remainder? 1. Okay. So at the end you have got 1 as remainder. So if that's the case, then what you do? Start noting it down from here. You have got 1 1 1 1. This is your binary equivalent of 15. Okay. The other quickest possible way would be you want to convert 15, right, to a binary number. So what you can do is start writing like this: 1 2 4 8 16 32. And now you want to make what 15 altogether, right? So look into this table, look into this numbers. What is the value which is very near to 15 but not exceeding 15? 8. Write 1 here. Okay. Subtract this 7. That means you have taken already 8. Now you have to construct 7. Now what is the next highest possible value which is very near to this 7 not exceeding 7? 4 1. Okay. So 7, you extracted 4. You are left with 3. Now again 3. What is the next nearest value? 1. 2 is also gone. 1 left. 1, which means this is the binary equivalent of 15. Okay. So let's try that with one more example. So let's say 1 0 1 0 0 1. Okay. Now somebody gave you this binary number and they ask you, can you tell me what is the decimal equivalent of it? So what you can do is start writing like this: 1 2 4 8 16 32. Right? Write it like this. Now what you do? You have got 1, so bring it down. You have got 1 here, so bring this value down. And you have 1 here, bring this value down. You have 1 here, bring this value down. 32. Add all this. 32 plus 8, 40. 40 plus 1, 41. So 41 is the decimal equivalent of this binary. Okay. Now in case of your binary, what actually formula you apply is, you'll always say into 2 to the power 0. You'll say into 2 to the power 1. You'll say into 2 to the power 2. You'll say into 2 to the power 3. You'll say into 2 to the power 4. You'll say into 2 to the power 5. Right? So 2 to the power 0 is 1. And hence you have written here 1. 0 and 0 you don't care. Okay. Now this is 2 to the power 3 and hence you have written here 8. Again, this is 0, you don't care. This 2 to the power 5, 2 to the power 5 is 32. And that's how it works all together. Again, we got 41 here. Let's assume somebody gave you 41 and they want you to convert that into a binary. So what you would do? Again, construct the table. 1, 2, 4, 8, 16, 32, 64. Okay, done. Right? Till you don't surpass this number, 41. Don't stick to 32. Write one more value here, 64. Okay. Now, what is the nearest value of this 41 here, which is not exceeding 41? Okay. So 32. Write 1 here. That means you've taken 32 from 41. 41 and 32. What is left? 32 plus 8 is 40. That means 9. 9 is left, which means you have already taken 32 now. Now you are supposed to extract 9 also from here. How can I extract 9? 16? No, 8. Okay. So if I put 1 here, then I have extracted 8 also. What is left? 1. How do I extract 1? Okay. Fill the remaining with zeros. So 1 0 1 1 0 1 0 0 1. That's how you convert a decimal to binary. Okay. Now in your binary system, you basically have only 0 and 1 as the possibilities, right? So that's the reason you're always saying 2 to the power, right? Because you have only two numbers, 0 and 1. Now if I talk about octal, in octal you have 8 possibilities. Octal 8. Okay, when I say octal 8, that means it starts with 0 and ends at 7. Okay, now let's see how to convert a octal to decimal. Now let's see the process. Okay, suppose somebody gives you an octal number. Let's say this is your octal number 173. So remember, in your octal number you'll have numbers from 0 to 7 only. So if I just say, let me pass 8, 183, convert. So let me be very honest, this is not a valid octal number. Why? Because an octal number cannot have 8, 9, right? It can go from 0 to 7, but not 8. It should not touch 8. For example, if you talk about binary can have only 0 to 1 and not 2, right? So this is not an octal number, 173. So when we do this, then what happens is, if you want to convert that to decimal, then you'll go ahead with this formulas here. 173 is equal to 173, and you convert that to 8 to the power 0, 8 to the power 1, 8 to the power 2, and hence it becomes 123, which means the octal of 173 is 123. Octal of 173 is 123. Okay, this is decimal and this is octal, right? So let's say you are given a number 123, a decimal number, and you are supposed to convert this into octal, which means now you'll start dividing it by 8. So you'll say 8. Okay, so divide this by 8. How much you'll get? Let's see. So 8 1s are 8, 9 10 11 12, 4 is reminder here, 43 I got. Okay, now 8 5s are 40 and I got 3 here. Okay, now I got 15. Again divide this by 8. 8 1s are 8, 8 2s are 16, right? So 8 1s are 8. So what is left over? 7. All right. Now I think I'm done with the division. So start from here and write it 173. And that's your octal number of this 123. Okay. Now I got octal. So somebody gave me 173 as an octal. They said that it is an octal number. Convert this to decimal. So what you will do? You start writing like this: 8 to the power 0, 8 to the power 1, 8 to the power 2. You'll add this. Now see here. 8 to the power 0, anything to the power 0 is always 1. This is 1. 1 into 3 is 3. Plus 8 to the power 1 is 1. 8 7s are 56. Okay. Plus 8 to the power 2 is 8 8s are 64 into 1. Okay. Now add this thing together. So it is 64 plus 56 plus 3, 123. This 173 got converted to decimal as well as 123. Okay, otherwise you can do something like this: 173 is here. Okay, now in case of your binary, you are writing 1 2 4 8 16, right? Likewise you can write 1 and then you write 8. 8 is 64. Again you write 8 into 8 into 8. Again you write 8 into 8 into 8 into 8, whatever, right? And then multiply like this. So it's like 3, it's 56, it's 64. And when you do this, you get a decimal equivalent of it. Okay. Likewise, if you talk about hexadecimal, in hexadecimal, you have numbers from 0 to 15. There are 16 possible values. Okay. Wherein you'll have 0 to 9, and then you have 10, 11, 12, 13, 14, and 15. Okay, and 16 does not exist, right? Because there are 16 possible values. So 0 to 9 would be represented as it is, and 10 is called A, 11 is called B, 12 is called C, 13 is called D, E, F. So you have A to F. Okay, so let's look into this example as well. So we'll go back to the screen. Let me say I want to convert hexadecimal to decimal. Okay, let me write some hexadecimal. 5C 92. Okay, so let's see this conversion. The hexa number 5C, if you convert that to decimal, then it should be 92. Okay, so let's go back to the screen again. So 5C is 92. Let's see how. Okay, the question is, convert this 92 to hexadecimal. How do you get that? Now you start dividing this 92, but what is the divisor now? 16. Okay, 16 5s are 80. Okay, so what is the leftover? 80 and then 12. Okay, I got 12 here because 16 5s are 80 and the leftover is 12. And now you cannot further divide this 12 in case of hexadecimal, right? Because you can divide only number if they are greater than 16, greater than or equal to 16. Okay, okay, so now what you do? Write it like this: 5 and 12, but 12 is represented with C, so it's 5C. Okay. Similarly, if you're given a number 5c, I'll write it here. And if you are supposed to convert this to hexadecimal, then what you'll do? So hexadecimal means 16, okay? So you'll say 16 to the power 0, 16 to the power 1. 16 to the power 0 is 1. This is 1. And this c is nothing but your 12. So you'll say 12 into 1 is 12 plus, okay? 16, 1 is 16. 16 into 5 is 80. 80 plus 12 is 92. Okay, so you should understand the conversion also, because it helps you out to understand how the number systems are all arranged.